Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge IGCSE Additional Mathematics Paper 1, which you're not allowed to use a calculator. And this is for examinations from 2025 Specimen paper. Let's start. Question 1. The diagram shows a graph of y equals modulus of f of x, where f of x is a cubic function. Find the possible expressions for f of x in factorized form. Well, we know that cubic graphs can either go like this or they can go like this. And in this case, the two equations will be like that. So it's either like this or the other way around, like this. Alright, so first let's find the positive equation, because then if we just negate everything, that means it'll just become the negative equation. And it does not matter if we negate f of x since it's inside a modulus function, so it'll anyway give this graph. So first let's find the positive function, or the function where in ax cubed plus bx squared plus cx plus d, a is positive. Then it'll give this shape. So firstly we know the three x-intercepts, which means that the brackets will have x minus minus 1 times x minus 0.5 times x minus 2. That's equal to y. Also, don't forget we might have to multiply by some constant a. So y will be equal to a times x plus 1 times x minus 0.5 times x minus 2. And how do we find what this a constant is? Of course, we use the y-intercept. So the y-intercept means x is equal to 0, and that's equal to 10. So 10 is equal to a times 1 times minus 0.5 times minus 2, because we're substituting x equals 0. So that's going to be simply a. So a is equal to 10. And this y value is going to be the modulus of f of x, right? So the modulus of f of x is going to be equal to this whole function, 10 times x plus 1 times x minus 0.5 times x minus 2. Now the values for f of x is simply going to be the positive or negative of this expression. But then there is one thing which we can simplify here. We have x minus 0.5. The 0.5 is a decimal, but usually we'd like to write this in form of all integers, right? So we have a 10 at the front. We can multiply 10 times this, which is 10x minus 5. But then we can factorize a 5 from this, so 5 times 2x minus 1. So this is equal to 5 times 2x minus 1. And therefore, we can multiply by these two to get f of x is equal to positive 5 times 2x minus 1 times x plus 1 times x minus 2. Or f of x is equal to negative 5 times all of this. And this will be our answer. Let's go to question 2. The polynomial p of x equals 6x cubed plus ax squared plus bx plus 2, where a and b are integers, has a factor of x minus 2. A. Given that p of 1 is equal to minus 2 times p of 0, find the values of a and b. Alright, we know that this p of x has a factor of x minus 2. So using the factor theorem, that means when we substitute x is equal to 2 into this equation, this will become 0. So p of x is equal to 0 at x equals 2. In other words, p of 2 is equal to 0. So that means 48 plus a times 2 squared plus b times 2 plus 2 is equal to 0. And 4a plus 2b plus 50 is equal to 0. Now we have another piece of information. P of 1 is equal to minus 2 times p of 0. So p of 1, that's going to be 6 plus a plus b plus 2. That's equal to minus 2 times 6 times 0 plus a times 0 plus b times 0 plus 2. So that's just 2. So this means a plus b plus 12 is equal to 0. Now we can solve for a and b using the two simultaneous equations. We have equation 1 and equation 2 here. So we can multiply this equation 2 by 2. 2a plus 2b plus 24 is equal to 0. Now you can subtract the equations. So we have 4a plus 2b plus 50 is equal to 0. And when we subtract this, we get minus 2a is equal to 26. A is equal to minus 13. Now we can substitute this for b. So we substitute a equals minus 13 here. And that means minus 13 plus b plus 12 is equal to 0. B is equal to 1. Now we have our two values, and that's our answer. B. Using your values of a and b. 1. Find the remainder when p of x is divided by 2x minus 1. So when p of x is divided by 2x minus 1, we can just do long division. So 6x cubed minus 13x squared plus x plus 2. Dividing by 2x minus 1. So how do we make the front term, which is 2x, into 6x cubed? We'll multiply by 3x squared, right? So multiplying the whole thing by 3x squared. 6x cubed minus 3x squared. Now subtracting off, we get minus 10x squared. Of course, in the quotient, we write 3x squared. Now how do we make this minus 10x squared from 2x? Of course, you multiply by minus 5x, right? So when we bring this plus x down and multiply this whole thing by minus 5x, so minus 10x squared plus 5x, and subtracting this off, we get minus 4x. And then, of course, we add a minus 5x here, and plus 2, right? Minus 4x plus 2 here. Now, how do we make this 2x into a minus 4x? We multiply by minus 2, right? So when we multiply by minus 2, this becomes minus 4x plus 2. And when we subtract both off, we get a remainder of 0. So the remainder is 0. That's our answer. Part 2. Factorize p of x. Well, we know two of the factors already. We have a factor of x minus 2 from the question, and the remainder is 0 for this b part 1 when dividing by 2x minus 1. So this is also a factor. So when we factorize p of x, so since we've already done long division in the first part of 2x minus 1, so you can write p of x is equal to 2x minus 1 times 3x squared minus 5x minus 2. And we know that x minus 2 is another factor. So we have to just factorize this such that it is x minus 2 times something. And this something is going to be 2x minus 1 times x minus 2 times 3x plus 1. And this is our final factorization. Well, how did I get 3x plus 1 over here? So I have this factorization here, 2x minus 1 times a quadratic equation. And we can split this quadratic into 3x squared minus 6x plus x minus 2. Now I can factorize these terms here. That's going to be 3x times x minus 2 plus 1 times x minus 2. It's basically the same thing as x minus 2. So now you can factorize this whole group of terms out. And we'll simply get 3x plus 1 times x minus 2, which is what I've written here. And of course, we just bring this down from the previous expression. And this is our factorization and our answer. Question 3. In this question, all angles are in radians. A. Write down the amplitude of 2 cosine of x by 3 minus 1. Well, the amplitude of any cosine graph is defined by when the cosine graph is a cosine of bx plus c. This a value is the amplitude because that is how high or low the graph goes. Like from the x-axis, the maximum height or the maximum depth is the amplitude. In this case, it's 2. And now for part B, write down the period of 2 cosine x by 3 minus 1. Well, in that formula which we have, which is a cosine of bx plus c, where x is an angle in radians, the period is going to be 360 divided by b. And in this case, bx is equal to x by 3, or in other words, b is 1 by 3. Now that means it's going to be 360 by 1 by 3, the period, So 360 times 3, which is 1080 degrees. You can write this in radians if you want. Divide by 180 and multiply by pi to get 6 pi radians, which is also correct. That's our answer. C. On the axis below, sketch the graph of y equals 2 cosine of x by 3 minus 1 for negative pi less than x doesn't equal to 3 pi. Well, first let's just convert all these to degrees since we're more familiar with degrees. If you're more familiar with radians, you can keep it like that as well. So always convert to which one you think you like more. So minus pi minus 180. Remember, multiply by 180 and divide by pi to get the value in degrees. Now this will be 180 here, 360, and 540. Now to sketch the graph, we need to find the coordinates of the points where the x values are given. These points, minus 180, and then we have the origin 0 as well, 180, 360, 540. So in order to sketch the graph, we need the values, the y values of the points where x is minus 180, 0, 180, 360, 540. Therefore, we can just substitute this x equals minus 180 into the equation. So 2 times cosine of minus 60 minus 1. And you need to remember your trigonometry values since calculator is not allowed here. So cosine of minus x is equal to cosine x. And this cosine of negative 60 is just cosine of 60 as well. And cosine 60 is a half. You need to remember the basic angles. So cosine 60 is a half, and 2 cosine 60 is 1. And then minus 1, we get 0. So the point is 0 over there. Now, when x equals 0, that will be equal to 2 cosine of 0 minus 1. That's 2 times 1 minus 1, since cosine 0 is 1. And now we'll get 2 minus 1, which is 1. So at x equals 0, y is equal to 1. Now for pi, or 180 degrees, then 2 times cosine of 60 minus 1, which is going to be 2 times half minus 1, which is just 0, same as the one with minus pi. So this is going to be the point. Now for x equals 2 pi, so that's 360 degrees. 2 cosine of 360 by 3, or 2 cosine of 120 minus 1. How do you find what cosine 120 is? I'll remind you one more time, calculators are not allowed in this paper. So cosine of 120, this 120 is in between 90 and 180, right? It's between 90 and 180, and therefore that'll be the negative of 180 minus itself, or negative cosine of 180 minus 120. So we'll add negative cosine of 60, which is going to be at minus half. So 2 times negative half minus 1, that's just minus 2. So at x equals 2 pi, y will just be minus 2. And at x equals 3 pi, so that means 2 cosine of pi, or 2 cosine of 180 minus 1. And that's the y value. So cosine of 180 is negative 1. So minus 2 minus 1, which is minus 3. So we have minus 3 over here, where x equals 3 pi. Now we can simply draw a smooth curve to connect all these dots. And if you do it correctly, it should go something like this. That'll be our answer. Now going to question 4. The parallelogram OABC is such that OA is equal to A and OC equals C. The point D lies on OC such that OD is to DC equals 1 to 2. The point E lies on AC such that AE is to EC equals 2 to 1. Show that OB equals K times D, where K is an integer to be found. Well, first thing we can do is we can draw out the diagram. That's the easiest thing to do. Draw the diagram and then find everything. So we have OABC, which is a parallelogram, and this will be O over here, let's assume, and we have A, B, C. So OA is equal to A, OC is equal to C. The point D lies on OC such that OD is to DC is 1 is to 2. So it will be somewhere here. Of course, this is vector C, not point C, so I'll just draw some arrows on top. Another point E lies on AC, which is this line here, diagonal, such that AE is to EC equals 2 is to 1 as well. So let's just draw a dotted line for a diagonal, and AE is to EC is 2 is to 1, which means AE is 2 times of EC, so E will be approximately there. Now the question is to show that OB is equal to something times DE. First, let's find the position vector of B, OB. So we know that OC is equal to AB, and that's the vector C, right? Because these are parallel sides, so the vectors will also be equal. That's why it's given that's a parallelogram. So if this is C, then OB is going to be this plus this, A plus C. Now we know OB. Let's find OD and OE. So OD is the easier one of the two, so let's do that first. We know that OC is C, and OD is to DC is 1 is to 2. And OD plus DC is equal to OC, right? The whole vector, right there. So if we write DC is equal to 2OD, and that means OD plus DC is going to be equal to 3OD, and that's going to be equal to the vector C. So that means OD vector is going to be C by 3. Now we know what OD is, and we can find OE. So OE is going to be OA plus AE. How do you find AE? AE is just 2 times of EC, which is given using this ratio. Now if AE is 2 times EC, we can write that AE plus EC, which is AC, that'll be equal to 2 times EC plus EC. And that means, let's just write this down here, AE plus EC is equal to 2 times EC plus EC, which is equal to 3 times EC. And that's going to be equal to AC. And what is AC? AC is just OC minus OA. Or in other words, AO plus OC, it gives the same thing. So just C minus A. So EC is equal to 1 by 3 times C minus A. So now we found another vector. It's very useful. Now we can find AE. Of course, you could also use OC plus CE, which is the reverse of EC plus OC to get OE. But yes, I'm just doing it in another way, which is to find AE and then add these up anyway. So, finding AE, that'll be equal to 2 times EC, which is 2 by 3 times C minus A. Now, if AE is equal to 2 by 3 times C minus A, what is OE? It's equal to OA plus AE. That's going to be A plus 2 by 3C minus 2 by 3A. And that's 1 by 3A plus 2 by 3C. Now we can find what is DE, which is the vector we need. Of course, we already found OB, another vector which we need, so that's also good. Now, since we have this vector OB and we can find vector DE, we can compare them. So, first finding vector DE, it's going to be equal to OE minus OD. And this is going to be equal to this value right here of OE, this one right there, minus this value of OD here. And that's going to be equal to 1 by 3A plus 2 by 3C minus 1 by 3C. Because we negate this and C by 3 is just 1 by 3C, right? Same thing. So now, this is 1 by 3A plus 1 by 3C, which is 1 by 3 times A plus C. I'm writing the arrows on top, by the way, since these are vectors and they're not just variables, right? Usually we write A, B, C and stuff like that as variables, but in this case they're not. Well, now, how do we prove that OB is equal to KDE? Well, we know that OB is equal to A plus C, right? And DE is equal to 1 by 3 times the same A plus C. So that's going to be equal to 1 by 3 times OB. And because of this, we can write therefore OB is equal to 3 times DE. And now we've proven the whole point of the question. You have to prove that OB is KDE, where K is an integer to be found, and of course, in this case, K is 3. That's our final answer, with 5 marks, of course, for all of this working. The diagram is unnecessary, but it really just helps you to visualize things much better. Now we can go to question 5. A. Given that log base A of P plus log base A of 5 minus log base A of 4 equals log base A of 20, find the value of P. Well, we can use the fact that these all have the same base in all the sides. So, using logarithmic laws, log base A of 5P by 4 is equal to log base A of 20. Now, if we do A to the power of both sides, we can completely eliminate the log base A from both sides. So 5P by 4 is equal to 20. And that means P is equal to 4 by 5 times 20, which is 16. That's our answer. B. Solve the equation 3 to the power 2x plus 1 plus 8 times 3 to the x minus 3 is equal to 0. This might look like a complicated equation to solve, since it's involving multiple powers of 3, and it looks like an exponential equation. But there's one thing we can do to manipulate this equation to make sure it's quite easy and we can change it into something we know. And what is that? First of all, let's write this 3 to the power of 2x plus 1 as 3 to the power of 2x times 3 to the power of 1. So that's just 3 times 3 to the power of 2x. So 3 times 3 to the power of 2x plus 8 times 3 to the power of x minus 3 is equal to 0. And now this 3 to the power of 2x is just 3 to the power of x, the whole squared, right? Now we can just write a substitution of y is equal to 3 to the power of x. So let y is equal to 3 to the power of x. The reason is to make this a quadratic equation. This is why we simplified 3 to the power 2x plus 1 into 3 times 3 to the power 2x. So now 3y squared plus 8y minus 3 is 0. And by splitting the middle term, this 8y is just 9y minus y. So 3y times, using factorizing this, so 3y times y plus 3 minus 1 times y plus 3 is equal to 0. So 3y minus 1 times y plus 3 is equal to 0. And y is equal to 1 by 3 or minus 3. Now, remember that substitution we made earlier. Y is equal to 3 to the power of x. We just have to revert this. So 3 to the power of x is equal to either of these things. So 3 to the power of x is equal to 1 by 3 or minus 3. But 3 to the power of x cannot be a negative number. Or actually, anything a to the power of x, if a is positive, this cannot be a negative number. Therefore, this case is rejected here, because it is negative. So 3 to the power of x is 1 by 3. And that means x is equal to log base 3 of 1 by 3, which is just log base 3 of 3 to the power of minus 1. And this will just be minus 1. So the answer is x equals minus 1. Now for part C. Solve the equation 4 log base y of 2 plus log base 2 of y equals 4. Well, we can see that there's two different logarithmic functions here. Log base y of 2 and log base 2 of y. But then if you do 1 divided by this, we get this. So we can rewrite this as 4 divided by log base 2 of y plus log base 2 of y is equal to 4. Now we have two of the same function. If you're still wondering how we got this, it's because log base a of b is equal to 1 divided by log base b of a. You can just swap the base like that. That's it. It is a formula and a rule to remember. So now we can multiply all the sides by log base 2 of y. So 4 plus log base 2 of y the whole squared is equal to 4 log base 2 of y. Now if we make a substitution just like we did in the previous part, 5b, we can just do it for let x is equal to log base 2 of y. Now that means x squared minus 4x plus 4 is equal to 0. Of course, when we bring this to the other side. That means x minus 2 the whole squared is equal to 0. You have to realize that this is a perfect square, because when you take x squared minus 2x plus 4, splitting the middle term once again, x times x minus 2 times x minus 2. And we get x minus 2 times x minus 2, which is just what I've written, x minus 2 the whole squared is equal to 0. And that means x is going to be equal to 2. And of course, we made the substitution. We have to undo it now. So that's going to be equal to log base 2 of y. Now if we do 2 to the power of both sides, 2 squared is equal to 2 to the power of log base 2 of y. And the 2 to the power and log base 2 cancel out. So y is equal to 4. And that's our final answer.